Okay, welcome everyone. My name is Aaron Holmes, and this is my project that I did for financial engineering analytics. Now, for my project, I chose to do an analysis of some financial engineering models. Specifically, these are asset dynamic models described in, I believe it's chapter 11 of Investment Science, our textbook. Uh, and Specifically, it's these three models here: the binomial lattice model, the additive model, and the multiplicative model. Now, in order to test these models, obviously I need some data. Um, so the data set I'm using is from UCI Machine Learning Repository, uh, and it's a sample of the Dow Jones Industrial Index from 2011. It's about 6 months worth of data. Um, as you can see, it's got quite a bit here. It's got 30 different stocks over 6 months, like I said. Um, and this data is pretty ideal because it's split up into 2 quarters. So the uh, first quarter of data um, is works nicely as a training set of data to develop like parameters or whatever your program needs. And the second set of data can be used as a test data set so that you can see how well your models perform. So before I go much farther, I should probably um, explain a little more about what these models are if you're not familiar with them. The first model is the binomial lattice model, and this model starts at the first time period. It starts with just one value, and one value, the stock price, and then that value is scaled up and it's scaled down. And it also has some associated probabilities that are carried along with it. At the next time step, things get a little more complicated because you have to scale the previously upscaled value up again and down, and then you have to scale the previously downscaled value up and down. Fairly quickly you can wind up with a very large number of potential prices, and what's interesting about this is it also includes a probability with each one of the prices involved. Now the other two models are a little different. Instead of having a big array of potential values, excuse me, both of these models start out with one single price and end with one single price. The additive model scales the starting price and then adds a random value to it to achieve the second time period's price. And then that process is repeated again and again until it reaches the end. The multiplicative model is a little different in kind of some subtle ways. It actually includes the randomness into the scaling value itself instead of adding it on later, which potentially solves some bugs that might run into, but it's probably fairly unrare. Both of these models also don't include any kind of known probability with them. They're just kind of, the scale price is kind of what you get. So in order for me to implement with all this data and with all these different models, I obviously used programming language. I use Python version 3.6, as you can see up here at the top, and I'm programming it using a Spyder IDE. So I thought I'd just walk you through this, since this is kind of the guts of the project itself. Up here at the top, I'm mostly just loading in the data, and like here, I'm converting the data into actual numbers, so the computer can process them. And here's where I save it into a data frame, so they can be easily accessed later. Right, and now down here we're getting to the point where I'm actually computing the parameters for the first quarter. You can see I split off the first quarter data here, so I'm able to access it without getting messed up with using any second quarter data in my test data set. So here I'm going through all the different stocks in the data set, and I'm getting a list of their prices and the changes. And here's where I calculate the mean and the standard deviation, or excuse me, it's the growth rate, not the mean, and the standard deviation for each stock. And so if we move down a little bit, here's where we use those variables. Using them here, here's one to calculate what the up value is going to be, and the corresponding down value, and additionally the probabilities associated with those. And here's where I run through the lattice and calculate the values. So it's the starting price times, like for the first one, it'd be the down value would be 0. So and the up value would be to the 12th power. So and then the same thing goes for the probabilities. You have the up probability to the 12th power, and the down probability to the 0th power for the first run through, and then the second run through would be the up value to the 11th power and the down value to the first power. So works out pretty nicely that way. You don't have to run through and calculate every single value. You can kind of skip to the end, which is nice. Right. And down here is where I do kind of a similar thing with the additive model. Here's one of the parameters required, the scaling value. And here, since you can't just skip to the end, I'm just looping through and just here's where the actual calculation is. I'm just looping through that 12 times and scaling the previous times value by this normal random value. And here's the multiplicative model. So it's fairly similar as the parameters. That's where you work those out. And then, so you can see here, that's where the normal the random value is incorporated with the scaling value. And here's where the actual calculation takes place. So it's pretty straightforward, hopefully. And then down here, I'm just collecting the results into one kind of box that I can easily look at. That's pretty much all that this part is. So if we run that, we can see here's a kind of little sample of some stuff that's going on, and here's where the actual outputs are. So you can see that this is kind of the whole point of this whole thing. So you can see you got one index, one row for each stock. And then here, this first value here, and this is stock AA if you're interested. This first value, 15.23, that's what the test data's ending value is. So that's what kind of the goal we're trying to get to is. And then 17.3, that's what the first model, the additive model's prediction was. And then this 15.4, that's what the multiplicative model's prediction is. And this 18.03, that's what the binomial lattice's prediction is. So you can see you got all of those for each different stock. So if we come back over here to the presentation, I can show you that a little clearer. This is basically the same data that I just showed you. It's the blue columns are the actual stock price, the test data's stock price, that goal we're trying to hit. The orange column is the additive model's prediction. The gray model is the multiplicative model's description. And the yellow model, or yellow column, is the binomial lattice model's predictions. So you can see, like this BA stock here, that one, the multiplicative model got a little carried away. Same thing with this UTX stock down here. But there are other stocks that the multiplicative was much closer. So, like for example, the AA stock, the multiplicative one's the closest. So to make a little more sense out of that, I came up with this table. What this is the real stock price, the test data's ending price, minus the predicted value for each model. So now that we have that difference, like average the differences for the additive model, and then for the multinomial model, and then for a binomial model, and same thing with the standard deviation. So they, to give you a little more information on how well they did. And as you can see, the additive model is only about 3 points off on average, which is not bad. It has a standard deviation of 6, so it's 6. And then the binomial lattice model did pretty well and had even lower standard deviation. There are a couple of them that the multinomial model exaggerated quite a bit on, so it's got a obviously higher average and quite a bit higher standard deviation. So that's about it. Thanks for your time.